Hello everyone, I'm Jasper. Here I'll show you how to use the recorder object to record training data for latent terrain. In the previous video, we talked about how to use the terrain.encode object to gather latent trajectories, and use the GUI, the X and Y pad, to gather spatial trajectories. So today we'll extend that to a three-dimensional control space, and we'll use the nn.terrain record object to record the trajectories by ourselves. So I have made these three sliders, and I've used a node object in Max to interpolate between presets from them, so that it gives me this three-dimensional controller. But you can also imagine that to be any sort of X, Y, and Z from a coordinate system, or any kind of input space that has 3 degrees of freedom. And we'll be using an autoencoder called music to latent. The original model is the work by Marco Pesini and their colleagues. We'll be using a scripted version of it so that it will work with nn.terrain in Max. I'll put a download link to the video description, so make sure to download the music2latent.ts file and make sure that your Max is able to locate that file. So first we'll load the model into nn.terrain, and using the decoder only, we'll also need to set the buffer size to 16,384, which is 2 to the power of 14. That is because the music to latent model has a slightly larger compression ratio. So see that this is kind of a giant autoencoder in terms of the size of the latent space. This is a 64-channel latent signal. So in our nn.terrain object, we will need to set the input dimension to 3 because we have a 3-channel control signal, and the latent dimension to 64. That is a lot of patch code to connect, and we definitely don't need to do that by hand. So if you go to the help file of nn.terrain, in the last tab, you can see that we have a JavaScript program to automatically connect all of the patch code. So we just need to copy and paste the v8 connection object, and we'll paste that into our main patch. And we'll need to go to the inspector and assign a script name for it to work. We'll just call it terrain. And we call the decoder the decoder. And now I'll use the message connect from terrain to decoder and from inlet 0 to 64. So you will automatically add all of these connections. And as always, we'll need the latent trajectory and the spatial trajectory to build our terrain. Last time we used the terrain.encode object to get the latent trajectory, but this time I would like to show you how to use the nn.terrain.record object to record our latent trajectories. So this gives us a bit more freedom to kind of intervene into the process. So first we'll create an nn.terrain with music to latent using the encoder, and we'll set the buffer size to 16,384. And this will produce the latent trajectory, so we'll use a recorder to capture that. So the recorder here will set the latent dimension as 64, and here the buffer size will need to set that to 4096, and that is because 4096 is the compression ratio of music to latent. So if you're unsure about the compression ratio of your autoencoder, sticking to the default is also fine. But you might get some duplicated latent, but that is not a huge problem. And we'll also add the script name to these two objects as well. So the encoder we'll call encoder, and the recorder we'll call recorder. And I'll send a message, say connect from encoder to recorder, 0 to 64. And we can add a number box at the first outlet because that will tell us the length of our trajectory. And we'll add a dictionary with a name, we'll call it latent.music2latent, and that will store the recorded trajectory. And now I'll create a attribute UI object and make sure this is recorded as latent. And we can use the record attribute to start and stop the recording. So we'll use one of the built-in content in Max, the prime loop, to produce latent vectors. And just a bit of technical stuff. For music to latent, we'll need to first set both of these models to GPU and set them to enable. We'll need to let the model to run for a while until we heard this noisy sound. So that means the GPU, the model is warmed up, is ready. So now we can start playing the sample, and I will wait and start recording. I'll wait for it to record an entire loop. Good, so now we see that we have 91 latent vectors. And now we can move on to record our spatial trajectory. So we'll use the same nn.terrain.record object with 3 input, and we'll set the buffer size to 4096 as well. But this time we'll need to make sure that in the record as attribute, we set that to coordinates. And then we'll connect the 3 control signals to our recorder. So right after I start recording, I'm going to quickly move around the knob so that it creates a trajectory of these 3 sliders. So now I'm going to start. Right, so see that the length of our coordinates is roughly the same as our latent. That is alright. I will create a dictionary object again. I'll call this coordinates.music_to_latent and use that to store this. And I'll bend the recorder so that it produces the data to our dictionary. So now we have both of these dataset ready, the latent and the spatial trajectories, and we can pass them to our terrain. So in the console, it says 1 latent and 1 spatial trajectory are loaded, so that looks good. Alright, so now we can add the train message. We can add a metro to keep the training going, and we can also monitor the loss by routing the last outlet to loss, and that should go to a floating number. I can also go to the inspector and set GPU to on, so in that way the training will use my graphic card. And now we can start the training. So see that our loss is going down, so that will be a good indication. And if you're familiar with deep learning, we can go to the inspector, and in the training section, we do have some parameters to play with. And also in the reference, you can see we have some argument, and that is where we can change some of the configurations of our model, which we haven't covered that much in the tutorial series, but some of them can get quite critical. So I do encourage you to take a look. So it has been trained for about a minute. I'll stop here, and now the final step is to connect the control signal directly to the 3 inlets of our terrain. So now I can set the terrain to enable, the music to latent to enable as well, and put that on GPU. Alright, so that is how to use the recorder and how to create a terrain with more than 2 inputs. So thanks for watching, and I'll see you next time.